Hello friends, welcome back to Golang advanced tutorials. So in the previous video we have seen some file related operations, temporary file creation, temporary directory creations and file permissions, etc. Today we are going to see some other interesting topics in the advanced Golang. Let's get started with our session for the day. I am opening the terminal. Yeah. So one of our subscribers suggested to use micro editor. I tried it and found it is very useful. cd go demo, getting into our regular usual folder. Now we are going to see something called console input. How to get input from the console. We have seen command line arguments, we have seen assigning values to the variables and all, but this time we are going to see how to get input from the console. One of our subscribers asked this long before, but better late than never. I am posting that video now. So this presentation is going to concentrate on some of the subscriber requirements in the comment section. The first thing we are going to cover is console input in Golang. How to get a console input. Yeah. So we are going to use the micro editor. It is very much similar to the Pico Nano editor I am using. Yeah. So micro, I'm going to name the file as inputdemo.go. Yeah. So this is the editor screen. As usual, package main, and we are going to import. We are going to use buffered IO here and OS package. As usual, for all the input related operations, we used to have OS package, right? File input and all. Similar to this, for console inputs, we are using the OS package. Function main. So now what we are going to do, we are going to define a buffer reader. Since we have imported the buffer IO package, so I'm going to create a new buffer reader. So from where this buffer reader needs to read the input? It is from the os.Stdin. So standard input, which is nothing but a console input. So the input will be read from the console input, which will be prompted to the user. So when this is the reader I am initializing, this buffer reader is going to read the input from the stdin, that is the console. So I am initializing the reader. Yeah. So this is the initialization. Then we need to read a line now. So using the same reader dot read string. So what we are going to read? We need to read a line here. So I am mentioning the escape sequence for a new line. So until you hit a enter key or until you hit a carriage return carrying a new line functionality, everything will be read from the console input. So once the value was read from the console, it will be assigned to a variable. I am naming it as text. It carries one more error handle. If needed, we can have the error handle, but at the moment I don't need any error handles, so I am mentioning it as underscore. So we initialized a reader, a buffer reader with stdin as the stream to be capturing, calling the readString method, readString function inside the buffer reader with a new line or a carriage return statement. This new line character informs the Golang interpreter to capture the standard input until the user hits new line or hits enter. So the value captured will be stored in the text variable. If there are any errors, it will be handled here. So I don't need any error handling as of now at the moment for this program. Yeah. Now what I'm going to do, I'm going to print the output. So for that I need the fmt package. So as usual, we have seen fmt.Println. I'm going to print what we have read. So what this program needs to do, it will get an input and it will echo it back. So it's a very simple program to get console input. Yeah. Control Q, save, yes. Go run input demo. So it is waiting for user input. I am giving sample, going to enter. It will input a new line character, so the input will be stopped. Sample is the data printed here. So the input I gave is sample. It is printed along with the new line as well. This is a very simple console input statement. Let us see one more console input operation. This is to get a whole set of string until a new line character, right? The next thing we are going to see is a single character input. So it is like getting single character from the console. This is for the whole string, whole statement. Now we are going to see a single character input. Yeah. So we are going to use the same reader we used earlier. Reader. This time we are going to do readRune. readRune. This statement reads a single character. Yeah. So I'm going to name it as C. It carries three handles. It returns three handles for us. One is the character which we are reading, that is the ASCII value of the character. Another one is the size it read for that single character, and another one is error handle, which I am not interested now. So three handles written from the readRune method. The first one is the character which we are reading from the screen, which we are reading from the console input. And the next one is the size, the amount, or the how big the character we have read, that is being returned. And the final thing is the error handler, which we are not going to handle now at the moment, right? So now our character is stored in the variable C. Similarly, I'm going to use fmt.Println C and fmt.Println size. So what is the size we are reading? The size in bytes. Okay, right. This is for the single character input. Yeah. Go run input. So this is the first statement we have given, which is from the read string. So this is first. It will echo back. Then it is waiting for us to give the single character. I am giving W. So the code for W is 119 and the size is 1. So this is what returned here for the single character input. What will happen if I enter a whole string instead of a single character for this? Let us try it. Run the code again. Give the first string, echoed back. Now it's time to enter a single character. I am giving a word here. Instead of a single character, I am giving a word. But what's happening here? It takes only the first character and ignores the remaining. So whatever you give as an input, but the readRune function will read only the first character from the input given. So this is for reading a single character. So this is for read a single char. Read a line. Right. So we have seen two ways of getting input. One is for the whole string, another one is for a single character, but both of them are using buffered input. Now we are going to see one more new mechanism for getting the input, which is called a scanner. Instead of the reader, we are going to use a scanner. So how we are going to use a scanner? The same way, buffer IO, instead of new reader, I am declaring a new scanner. The same way, the data to be scanned from stdin. So the same way, we need to get the scanner in a scanner object. So now our scanner is ready. We need to read the data. So how to read data from a scanner? We need to use our scanner object dot scan. This will read the data, but it is not going to return the data, and we can assign it to another variable like that. So there is a special function using which we can get the data which is scanned earlier in this statement. So this is the statement for console input. Now what I am going to do here, format.Println. Here I am going to use the same scanner object. There is a function inside this calling text. It returns the text which is read earlier. So the scanner.Scan statement prompts the user for the input. Once the user provided the input, it's stored inside the scanner. We can get the input stored inside the scanner using the scanner.Text function. Let us see how it goes. So we are running the file. So first it's prompting us for the actual string which we did earlier, right? The same read string. I'm giving it as first. It's echoed back. The second thing is the character, single character input, which I am giving Q. I got the ASCII code 113 for that Q. The third thing, it is still waiting for us to give the scanner input. So I am giving it as second. So we got it back again. So three ways we have handled the user input from the console. One is through the whole line, single character, and the final one through the scanner. This is about user input through consoles. Fine. Now we are going to see something related to the concurrency. In the previous videos, we have seen something called wait groups. So these wait groups are a group of Go routines waiting for that group to complete their process as a group. So it will create a group of Go routine processes, waits for the whole group to complete, then further process will be happening. It is to handle a variety of processes under a single group. This is called wait group. Let us see how a wait group performs. Already we have seen in a previous video. Check it in the link. Now I am going to explain it further because of some advanced concepts need to be explained along with the same. We will see them now. What I am going to do now is I am naming the file as waitdemo.go. Here the same kind of package main is there. I am importing, going to print something, so I am adding the fmt package, and whenever we need to deal with wait groups, it is inside the sync package, so I need to add sync as well. At the moment these are all the things I need, right? So what I'm going to do, I'm going to start with function main. So inside the function main, I'm going to declare a wait group. Yeah, variable, naming it as myWaitGroup. So wait groups should be declared as sync.WaitGroup. It is inside the sync package. So I declared a variable of type waitGroup now. So I need to create a bunch of processes for the wait group, a bunch of processes for this group. So how to do this? We can do this only using a loop. So for that, I'm going to define a for loop. Yeah, So a for loop will be a good option for this. I equal to 1, I less than, let us make it some big number like 500. Yeah, I plus plus. So this is the usual for loop we create in Golang. Now inside the for loop, I need to increment the wait group here. So then only the wait group will hold every go routine calls. So I need to increment the go wait group and make a go routine call. Both the things needs to be done here. First thing is incrementing the wait group, which is very simple, using my wait group dot add of 1. So for every call, the wait group counter will be incremented once. Next, we need to make a call. We need to make a call to the go routine. So I need to define a global variable which will be shared along with by the go routine and our main process. So I'm declaring a global variable count equal to 0. So this is the global variable I have defined. Now I need to write a go routine to handle the global variable. So my go routine is function. I am naming it as handler. Since our variable is count, I am naming it as countHandler. This is the go routine variable. It is a very simple code I am going to do here, which is count plus plus. I am just incrementing the count once. That's all. Nothing more than this. A very simple code I have written to increment a counter. Right. But here we are adding a counter to this wait group. Now we need to free free the go routine from the group. Then only the wait group will be decremented and at last it will become 0 and the program will exit. So for that I need to make the wait group process done. So if that go routine call is done, it will be decremented again. So for that I need to call the waitGroup.Done. So this is notify completion. Okay. So this will notify the wait group of completion. Right. We need the reference for the wait group here. So I need to add it. My wait group. So it is a reference. So I need to provide sync.WaitGroup. This is called by reference. So far in the functions and all we used to call by value. Here it is a call by reference. We are passing the pointers. Right. The function is countHandler. Right. So I need to make a call to that function. It is a go routine. Go countHandler. I need to pass the address. It's a pointer. My wait group. As simple as this. So what is the work of this for loop? This for loop gets incremented once. Sorry, this for loop creates a wait group and adds the go routine calls for every invocation. So the wait group gets incremented for every go routine call, and whenever a particular go routine operation completes, it notifies the wait group with the done statement, so it decrements the value, the counter back again. This is how we define the wait groups. Now this wait group completes its operation. Once the operation is done, what we are going to do, we need to print the final result. Yeah. So for all this operation to get completed, we need to make the wait group waiting. How to make a wait group waiting? My wait group dot wait. So this statement makes the wait group wait until all the go routines are completed, and now I am going to print println value. What is the value I'm going to print here? My global count. So what is the count value we are going to get? Let us see. Actually, it is supposed to be finished until 500, right? So for I value becomes 500, the count is also getting increased that much of times because we are calling the go routine inside the loop. Save it. Let us see what is it returning. I am running go run wait demo. The value is 476. Now I am running it again. The value is 447. Again I am running it 486. So every time when I try to run this particular code, this particular wait group, I am getting different values. What I am expecting is 500 because that is the number of times the loop is performed, that is the number of times this go routine is called. But what the thing is happening, the wait group is waiting, but due to some race conditions, the entire process of 500 calls not completed and it's exited with some other values which is nearer to 500 like 460, 470, 480. That means some race condition is happening between the go routine calls. How to handle these kind of race conditions? How to handle this type of problem? And we need to complete the wait group entirely. So we need 500 as the result every time when we make a call. How to do this? In order to do this, the only solution we have is Mutex, mutual exclusive locks. So what's happening here in wait groups is whenever one go routine call performs one operation, the other go routine call tries to go to the next line. Like that, the sequence of operation is being performed here, but instead of this done to happen, what's happening here is some threads based on the CPU prioritization, it is not waiting for the go routine to complete, but due to some race condition, it proceeds further and prints the value. Now what we are going to do, we are going to apply a mutual exclusive lock over this count process. So before and after this count process is happening, we are going to apply and release a lock. Then we ensure the count process is complete, then only the done will be processed. If the done will be processed, then only it will notify the wait group that it needs to decrement once and the process of go routine is completed. So this will ensure the completion of go routine process altogether collectively. Let us try how to use a mutual exclusive lock, which is called as Mutex. Let us copy the same code and we are opening the mutexdemo.go here. Yeah. Now what we are going to do, we are going to create a mutual exclusive lock. Yeah. So we are going to define it. The same sync package contains the mutex for us. So how to create a mutex? Variable. I am declaring the variable. I am naming it as mutex. Where this mutex is available, it is in sync.mutex. As simple as that. Now we are going to pass the reference of mutex to the count handler and x. We need to receive it here, comma, mutex star sync dot mutex. Right. So we got the mutex mutual exclusive lock reference here. We need to enforce the lock here. So how we need to enforce it? Mutex dot lock. This is the function used to enforce the lock here. Once the count operation is done, what we are going to do, the same mutex dot unlock. So we are releasing here. So only after the count is completed, we are releasing the lock. That means every go routine must every go routine must complete the count operation, and then only it will notify the wait group regarding its completion using the done function. So the race conditions will be avoided in this case. Let us see how it performs. 499, 499, 499. So every time it is returning 499. Why not 500? Because the for loop is I less than 500. I am making it as less than or equal to. Yep, it's 500 every time. So no race conditions are involved here. So this is the statement which creates a mutual exclusive lock. This releases the lock. So the lock ensures the count gets completed and then only notifies the wait group about the completion of the go routine call. So this is about mutex and wait groups. Yeah. Hope this added some value to the tutorials. This is one of the advanced concepts. So that's all about today's video. Please add your comments, recommendations, or your interested topics or the sections you want to learn more. I will definitely keep a note of it and do the needful. Thank you very much. Let us meet in the next video.